Hi children, how are you all? I hope all you are fine. Children, in the previous video what we discussed, we discussed about that up to types of fractions. Okay. In this video, continuation of that concept 2, we are having that rational numbers. Already rational numbers definition we discussed. What is the definition of a rational number, ma? A number which can be expressed in the form of p by q, where p and q are integers and q not equal to 0. Then that number is known as rational number. Yes or no? Now here, in how many ways we can represent that rational number? Okay, and what are the parts of that rational number? Actually, we are having that here terminating decimals and non-terminating decimals. About these all things we will discuss in this video. Okay, let us see here. First, I'll write that what is a rational number. Okay, once again see that what is the definition of that rational number. What is a rational number? Again, definition given in your material, ma. What is the definition here? A number which can be expressed in the form p by q, where p comma q are integers and q not equal to 0 is called a rational number. Yes or no, ma? This one only this is the definition of that rational number. Yes or no here? Now see that what is the definition? A number which can be expressed in the form of p by q. Okay, p by q means, for example here, what about this one, ma? What is this number? What we will call this one? This one as 2. Okay, we know that 2 is an integer. Is this integer, is it a rational number or not? How we can say that? Every integer we can express in the form of p by q, and we can say that every integer is a rational number. How we can write this one as p by q form means by writing 1 as the denominator. By writing 1 as the denominator. See that here actually we taken the number as 2. 2 by 1. Is there any change in that number? There is no change. Why? Because again after cancellation again you will get it as 2 only, no? 2 by 1 value is equals to again 2 only. Am I right? Now here 2 by 1 is that rational number. 2 by 1 is that rational number. And in the same way 2 is an integer. Am I clear, ma? That's why here every integer we can express in the form of p by q. Then we can say that every integer is a rational number. Am I clear, ma? Here see that actually what is the definition? P by q. In the denominator is it possible to take that 0, ma, here? If you will take that 2 by 0, then what we will get that as resultant? Actually rational numbers means that is related to quotient. That's why the set of rational numbers denoted by the letter q. Okay. Now here is what is that quotient, ma, here? 2 by 0. 0 into how much is equals to 2? Is it possible to get that 2 here? Not defined. Okay, this is undefined or not defined, no? That's why here 2 by 0 is not a rational number. Why? Because rational number is always depends on that the quotient. That's why here rational number represented or denoted by a letter. Denoted by a letter q. What is the meaning of this sentence? Means the set of rational numbers denoted by the letter q. Q means quotient, which means the rational number should be identified by using that quotient only. But here we are not getting that any quotient, no. That's why here if you will take that 0 as the denominator, then that is not a rational number. Why? Because at that cases quotient undefined. Okay, ma. That's why here q not equals to 0 condition must be applied. Q not equal to 0. Okay, ma. So this is about that rational numbers, right? Here we are taking that rational numbers. I will write that one of the rational numbers. Say that 2 by 3. Is it a rational number? Yes, of course, that is a positive rational number or negative rational number? Positive rational number. Why? Because both numerator and denominator are having that positive integers only, no? That's why this is a positive integer. Now come to that, minus 4 by minus 5. Is it a positive rational number or negative rational number? Yes, this is a positive rational number. Why? Because in that numerator we are having negative sign, in that denominator also we are having that negative sign. That's why we can take that these two are positive rational numbers. Positive rational numbers. Okay, next one, see that here minus 2 by 3 is there. Minus 2 by 3, is it a positive rational number or negative rational number? Negative rational number. Why? Because the quotient of one positive integer and one negative integer is always negative. That's why this is a negative rational number. And in the same way, 3 by minus 4 is there. Okay, here negative sign is there for that numerator and here negative sign is there in the denominator. Okay, at that cases these two are the examples of negative rational numbers. Negative rational numbers. So children, see that in natural numbers, in between 1 and 2, how many natural numbers are there? In between 1 and 2 here, how many natural numbers are there? 0 natural numbers are there, yes or no? Why? Because 1 is a natural number, 2 is a natural number. There is no any other natural number is existed in between 1 and 2. Yes or no? That's why in between 1 and 2, 0 natural numbers are there. 0 natural numbers are there. Understood? And in the same way, in whole numbers, in between 1 and 2, how many whole numbers are there? How many whole numbers are there? Again, no whole numbers in between those two. No whole numbers. Okay. In between, in integers, in between 1 and 2, how many integers can exist, ma? Here also 0. Okay. Now come to that rational numbers. Here in between 1 and 2, how many rational numbers are there? In between 1 and 2, how many rational numbers are there? Infinitely many rational numbers can exist here. Infinitely many rational numbers. Okay, ma. About this one, how to find that rational numbers which are lies in between any two rational numbers, that is the last concept in this total chapter. So we will discuss that one later, ma. Just to say that how many rational numbers are lies in between any two rational numbers means infinitely many rational numbers. Why? Because just observe that here 1 and 2 in between there is no any other natural number. In between 1 and 2 there is no any other whole number. And in between 1 and 2 there is no any other integer. But infinitely many rational numbers can exist in between 1 and 2. Not only in 1 and 2. You can choose that any two consecutive numbers. Infinitely many rational numbers can exist in between any two rational numbers. Understood, ma? Now here say that. How we can say that one? Here I am saying that. See. Here 1 is there. In between 1 and 2 I told you, right? I want to divide this 1 and 2. Actually this is one of the part. 0 to 1, one of the part. 1 to 2, one of the part. So here I chosen that 1 to 2 part. Okay. This part I want to divide it into 4 parts. I want to divide it into 4 parts. Then the first part I can represent as 1 by 4. Already I told you know how to write this one. And this one 2 by 4. 3 by 4. Okay. Actually here by 4, no? By 4 means this is 1 and 1 by 4. Okay. 1 and 1 by 4 means how much you will get here? 5 by 4 you can choose. Or else see that 0 to 1, 1 to 2. This is a 1 by 4, 2 by 4, 3 by 4, 4 by 4. Sorry, this is a 4 by 4, no? And this is a 5 by 4. Or else 1 and 1 by 4. Why? Because already from 1 onwards we are taking, no? So 1 and 1 by 4 also you can choose that. Okay. Next is 6 by 4, 7 by 4, 8 by 4. 8 by 4 after cancellation again you will get it as 2. Okay. And this one also I want to divide 0 to 1 also 4 parts. 1, 2, 3, 4. Okay, ma? 1 by 4, 2 by 4, 3 by 4, 4 by 4. Okay. Now, the same two parts again I want to take here. This is 0, 1, 2. Now, I want to divide that again same 0 to 1, 1 to 2. As that each part I want to divide it as 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 by 10, 2 by 10, 3 by 10, 4 by 10, 5 by 10, 6 by 10, 7 by 10, 8 by 10, 9 by 10, 10 by 10. How you will get that clarity means 10 by 10 we know that 1. So, at that place of 1 we got it as 10 by 10. Okay. And this is 11 by 10, 12 by 10, 13 by 10, 14 by 10, 15 by 10, 16 by 10, 17 by 10, 18 by 10, 19 by 10, this is 20 by 10, 20 by 10 again 2. Okay. Here I divided that 0 to 1 as 4 parts and here I want to divide it that 0 to 1 as 10 parts. Now I want to divide 0 to 1 as 100 parts. 0 to 1 as 100 parts. Is it possible or not? Yes, of course. 1 by 100, 2 by 100, 3 by 100 up to 100 by 100. 0 to 1 we are taking, no. Okay. And in the same way I want to divide that 0 to 1 as 1000 parts. That is also possible. That's why here how many numbers we can observe, ma? By dividing this one part into 4 parts means here we can observe that how many rational numbers can exist here. 3 rational numbers existed in between 0 to 1. In between 0 and 1 we are having that 3 rational numbers by dividing by 4. Here I divided that one as 10 parts. Now here we are having that in between 0 and 1 how many parts we are having, ma? Here 9 parts we have here. Okay. For example, if you want to divide that 0 and 1 as 100 parts, then the number will be increased or decreased? Number will be increased. And in the same way 0 to 1, I want to divide it as 1 lakh parts, then the number will be increased or decreased? It will be increased. Okay, ma? That's why here we can say that in between any two rational numbers, we have that infinitely many rational numbers. Understood? Yes. By using this concept, here see that 1 by 2 is a rational number or not? Of course, that is a rational number. Why? Because 1 is integer, 2 is integer, and that number we written in the form of p by q. That's why here 1 by 2 is a rational number, belongs to rational number. Okay. Now, we have an idea about the decimal numbers. Yes or no, ma? Decimal numbers means what? In that 6th class, we have the decimals concept. What is the decimals, ma? Decimals means here that is the combination of a whole number and a decimal part. Okay, by combining, by using that point, decimal point, by using the dot, what we will call the dot, ma? Decimal point. For example, 0.345 is there. Is it a decimal number or not? Yes, of course, that is a decimal number. Why? Because here 0 is the whole part and 345 is the decimal part. Okay, again we will discuss about the decimals, ma, end of this concept. See here, and this one we will call it as a decimal point. Decimal point. And this is a decimal part. Decimal part. And what we will call this one? Point before which one is there? That is an integer. Okay, and that is a whole part also we can say. Whole part or integer part. Whole part or integer part. Now here how to represent this one? See that by using that expanded form. How to write the expanded form here? We know that 0, 0 plus 3 by, here the first number how we can write, ma? First number as 3 by 10, 4 by 100 plus 5 by 1000. Okay. Why? Because again how to convert decimals into that fractions and how to convert fractions into decimals, we have an idea about that, right? Now here see that for example 3 by 10 is there. 3 by 10 how to convert into that decimal form? Here in the denominator how many zeros are there, ma? Only one 0 is there. That's why 0.3 we can write this one. Okay. And come to this one. 4 by 100 is there. 4 by 100. We can write this one as how many zeros are there? 2 zeros are there. 2 zeros are there means decimal point after must be 2 digits will be there. 2 digits will be there in the decimal part. Okay. Now here actually we are having here only one digit. What is that ma? 4. But here 2 zeros are there, which means in the decimal places we have the 2 places, but here we have only one digit. That's why we have to keep that 0 here. 0, 4. Now we have the 2 digits, no? Now 2 digits before we have to keep the point. Point before, is there any digit ma here? Not there. That's why again keep that 0. 0.04. Okay. And in the same way here 5 by 1000 is there. 5 by 1000 how we can write? See that here 3 zeros are there, which means 3 decimal places must be we should have. But here we are having only one digit, that is 5. If you will keep that 5 after 0, that is 50. Okay. 5 before we have to keep that zeros. Okay, why? Because 3 zeros are there, 3 places are there. 3 places before we have to keep the decimal point, and point before here any other digit is not there. That's why here we have to keep that 0. 0.005. Okay ma? If you will add that 0.005, 0.04, 0.03, sorry 0.3, again you will get it as 345. 0.345. Okay, already you have an idea no about this one. In that 6th class we learned about this, right? Now in this class what we will discuss means, see here ma, rational numbers we are saying, right? In that rational numbers we can represent it as 2 ways. What are those means? Terminating decimals. First one, terminating decimals. Second one, non-terminating decimals. Non-terminating decimals. Okay. What about that? Terminating decimals and non-terminating decimals. Okay. Now here see that. Rational numbers are represented as non-terminating decimals. Again we are having here non-terminating recurring decimals. Non-terminating non-recurring decimals. Non-recurring decimals. Okay. Now here which decimals we can call it as rational numbers means terminating decimals and non-terminating non-recurring decimals. Sorry, non-terminating recurring decimals. Okay. In that non-terminating decimals actually we are having here again 2 parts now. Okay, non-terminating recurring decimals and non-terminating non-recurring decimals. Now here which decimals we will call them as rational numbers means non-terminating recurring decimals and terminating decimals. Okay, and non-terminating recurring decimals is a part of non-terminating decimals. Okay, those decimals are non-terminating and in the same way those are in recurring. Recurring means repeating. Okay, recurring is nothing but repeating. Repeating. Okay, repeating decimals and non-repeating decimals. What we will call that? Non-terminating non-recurring decimals are irrational numbers. Irrational numbers. Okay ma? Here see that terminating decimals and non-terminating recurring decimals or non-terminating repeating decimals are known as rational numbers. Non-terminating non-recurring decimals are known as irrational numbers. Okay ma? Now here see that what about that terminating decimals and non-terminating recurring decimals. Okay. Now here see that how to convert into decimal. 1 by 2 how to convert into decimal form here. Yes. In that numerator which number is there, that one become as a dividend, and here in the denominator which one is there, that one become as a divisor. Yes, and 1 divided by 2. We know that division form, right? Now here 1 is smaller than 2. 1 is smaller than 2. That's why here keep that 0 and here also keep that 0 and apply that point. Okay. Now here 2 5s 10. Clear ma? That's why here how to write this one? 0.5. 0.5. And in the same way 1 by 3 is there. 1 by 3 how to convert into the decimal form? Again same process. 1 is divisible by 3. Okay, again 0 and here 0. 3 3 is 9. Again 10 minus 1. Sorry, 10 minus 9 is 1. Again 1 is smaller than 3. Again keep that here 0 is not required. No, that's why here again 3 3 is 9. Again 1. 3 3 is 9. Again 1. Okay, this process is in continuation or not? Okay, that's why here we can write this one as 0.333 and so on. That is in continuation. Am I clear to you? Yes. And here one more example, see that 22 by 7 is there. 22 by 7. Then how much you will get ma here? See that 22 divisible by 7. 7 3 is 21. Again 1.0717 again 7 4 is 28. 2 0 7, yes, 7 2 is 14. Okay, again here 6 60. Yes, 7 8 is 56. Okay, is there any ending point ma here? Here we are not getting that any ending point. Just check that again. Here 0. Again 7 5 is 35. Again 5 0. 7 7 is 49. Again the remainder as 1. Again the remainder as 1 means again the same steps will be in continuation again. Okay, see here ma. Again 1 0. Again 7 1 7. Again 3, like that we will get it, right? Now here see that 3.142857 and so on. 22 by 7 value. Now here see that which is equals to 142857 and so on. Okay ma. And one more example I will tell you, just to see that before going to that. Here 1 by 2 is equals to 0.5. 1 by 2 is equal to 0.5. Here 5 after any decimal value is there ma here? 5 after there is no any decimal value here. Okay, up to 5 here we got it as 0. Where we will get that a remainder as 0, then that is the terminating decimal. Okay, after dividing that given rational number, here wherever you will get that 0 as the remainder. If you will get that 0 as the remainder, then we can consider this one as a terminating decimal. Terminating decimal. Terminating decimal. Now come to this one. Here we didn't get that 0 anywhere. Again that process is in continuation. Here also we didn't get that 0. That process is in continuation. Okay, this kind of decimals are known as non-terminating decimals. We will call them as non-terminating decimals. Non-terminating decimals. Okay ma. And this one also non-terminating decimal. Am I clear to you? Non-terminating decimal means there is no ending point in that decimal part. There is no ending point in that decimal part. Then we will call those decimals are non-terminating decimals. And here terminating means exactly it has some ending point. Some ending point is there means somewhere we will get it as 0 as the remainder. Understood ma? So this is about that terminating decimal and non-terminating decimal. Now come to that, which one is which decimal we can consider it as rational numbers. Okay, terminating numbers, terminating decimals are rational numbers. Terminating decimals are rational numbers. And non-terminating, what about that non-terminating? Here see that in this non-terminating we are having the dots means and in continuation. But once observe that here the same number is in repetition. 0.333. 1 by 3 is equals to 0.333 and so on. Okay, in the decimal part one of the digit is in repetition. One of the part is in repetition. That's why we can write this one as 1 by 3 is equal to 0. Which number is in repetition ma? 3 is in repetition. So above that 3 we have to keep the bar symbol. We have to keep that bar symbol or vinculum symbol. Understood, ma? So this one is known as non-terminating. Why? Because there is no ending point. That's why we will call this one as a non-terminating recurring decimal. Recurring or repeating decimal. Repeating decimal. Understood, ma? So 0.3 bar is there, no? So we can convert that 0.3 bar as that. 0.3 bar we can again written in the form of a rational number, P by Q form we can write it. Okay, I will tell you that one how to write. See that? Okay, 0.3 bar. Which number is in repetition? Is there any number is in repetition and that is a non-terminating decimal? Then easily we can say that this is a rational number. This is a rational number. Hence we can say that which numbers are rational numbers, ma? Terminating decimals and non-terminating recurring decimals are rational numbers. What about that? Non-terminating, non-recurring. Non-terminating, non-recurring means which kind of decimals, ma? For example, here 2.346835783791 and so on, like this one of the decimal is there. Okay. Is this decimal, this is terminating decimal or non-terminating decimal? Wherever we can observe this kind of dots means simply we can say that that is a non-terminating decimal. Non-terminating. Non-terminating, clear. Non-terminating repeating decimal or not repeating decimal, ma, here? Non-terminating, okay, clear. This is non-terminating, non-repeating or repeating decimal. Here is there any place value, is there any number is in repetition? Repetition means in continuation only, okay, without giving any gaps, in continuation. For example, here 3, 4, 6, 8, here again 3 is there, okay, but 3 after which number is there? 5 is there, but here 4 is there, here 7, here 6, here 8, okay, here 8, okay, but this is not in repetition. Okay, ma, there are some gaps, right? Here in between 3 and 3 we have some gaps. Okay, 468 is not in repetition again. Okay, that's why here this is a non-terminating, non-recurring decimal. Non-terminating, non-recurring decimal. We can't convert this one as in the form of P by Q. That's why here we can say that this one is a non-terminating, non-recurring decimals are irrational numbers. Irrational numbers. Okay, ma? And this is a rational number. Understood? Okay. That's why here see that, and in the same way we can say that 20.2023, 2023, 2023 and so on, like this one of the number is there. 20.2023, 2023, 2023 and so on, like this there. Okay. Now is it non-terminating or terminating decimal? Dots are there means that is there is a continuation, which means there is no ending point. There is no ending point means that one consider it as non-terminating decimal. Non-terminating, clear. This is a non-terminating recurring decimal or non-recurring decimal, ma? See that 2023, 2023, 2023, 2023, that is in continuation, yes or no? The same number, one of the number 2023, 2023, 2023, okay, the same pattern is in repetition, yes or no? That's why here we will call this one as a repeating decimal or non-repeating decimal. Repeating decimal, why? Because the same period is in repetition. The same number is in that repetition. That's why here a non-terminating recurring decimal. Recurring or repeating decimal. Did you understand this concept, ma? Which one we will call? Okay. Now we can represent this one as 20.2023. Which number is in repetition? 2023 is in repetition. No, that's why here 20.2023 bar. Now is this number is a rational number or irrational number? Rational number. Why? Because here bar is there means that is repeating, no? So that's why this is a rational number. Okay ma, that's why first you have to observe that which one is a rational number and which one is an irrational number. Understood? Now here see that we are keeping that bar symbols, no? Here which number is there? Which number is there? That number is called period. The value which is there at the place of recurring. Okay? The value which is there at the place of recurring, that is called period. Number of digits are there in that recurring, that is called periodicity. Number of digits. Number of digits, that is called periodicity. Periodicity. What about that period and periodicity ma? Period means the value which is there in that recurring part, that is called the value. Okay, the representation of value which is there in the place of recurring. Which number is in repetition, that number is called period. Okay, in that number how many digits are there? How many digits are in repetition? That number of digits considered as periodicity. Understood ma? Once again see that here. 5.64321. 64321 bar. What is the meaning of that one? We can write this one as 5.64321, again 64321, again 64321, again 64321, which means that is in continuation. Yes or no? Okay, that's why here that is a non-terminating repeating decimal. Clear? Okay. Now we can write this one as here which one is the period and which one is the periodicity. Period, periodicity. Okay. Period means here what I told you ma, which value is in repetition. Which value is in repetition here? 64321. 64321 is in repetition, that's why that is a period. How many digits are there here? 1, 2, 3, 4, 5. 5 digits are there, so 5 is periodicity. Understood? One more example. 2.3456. Okay. On that 3456 bar symbol is there. Now here period. Which one is period ma here? Which number is in repetition means on that which number we are having the bar symbol 3456. So on that period 3456 bar symbol is there. So 3456 is the period. Now the periodicity. What is the periodicity here? How many digits are in repetition? 4 digits are in repetition. That's why periodicity is 4. Am I clear to you? Yes. Now here I will tell you one of that. Mixed recurring decimal. Mixed recurring decimal means for example 2.3478. 3478 is there. And the bar symbol is there on that 478 only. Observe this one carefully ma. 2.3478. Bar symbol is there on that 478 only. Okay. Now how to write this one? 2.3478. Which number we can write it again? 3478 or 478? 478 only. Why? Because the bar symbol is there on that 478 only. Okay. That's why 478, 478, 478 and so on. We should not write that 3 in repetition. Why? Because the bar symbol is not there on that 3. That's why we should not write 3 as in repetition. Clear ma? Yes. Now here what is that period and periodicity? Period and periodicity. What is the period here? Which number is in repetition? 3478 or 478? 478 is in repetition. That's why here period is 478 only. Okay. And what is the periodicity? How many digits are in repetition? 1, 2, 3, 1, 2, 3, 1, 2, 3. How many digits are in repetition? 3 digits are in repetition. That's why here periodicity is 3. Okay ma. So in this video what we learned? What about that rational numbers and how many rational numbers are lies in between any two rational numbers, and in the same way here we learned about that how to represent that rational numbers. The rational numbers how to represent ma? In 2 ways we can represent. One is terminating decimal, another one non-terminating recurring decimals. Okay, terminating decimals and non-terminating recurring decimals only known as rational numbers. Non-terminating, non-recurring decimals are considered as irrational numbers. Understood ma? So we learned about the difference also, no? What about the rational number and irrational number difference also we learned, and in the same way period and periodicity we learned. And here, why? Because here terminating decimals, again we can convert into that rational number, we know that. That's why we call them as rational numbers. Okay. Non-terminating recurring decimals are there, no? How to convert that non-terminating recurring decimals into that rational number? Okay, that concept we will discuss in that next video. Along with that, we will discuss about that comparison of rational numbers. Okay, thank you all.